B. 2 onto x minus 6 all squared plus 10 onto x minus 6 minus 48. So this expression is of the form 2 times f of x all squared plus 10 times f of x minus 48. So to be able to factor this expression, let's replace our f of x here with a variable, say y. Now we have 2y squared plus 10y minus 48 as an expression to factor. Well, before we go ahead and do that, we can factor out a 2, leaving us with 2 onto y squared plus 5y minus 24. Now, we have an AC here of negative 24. So what are two factors of negative 24 that add to 5? Well, in this case, two numbers that multiply to negative 4 and add to 5 are negative 3 and 8. So we have y squared plus 5y minus 24 factors to y minus 3 and y plus 8. But we need to include the 2 we factored out, so we have 2y squared plus 10y minus 48 equals 2 multiplied by y minus 3, y plus 8. Lastly, we need to sub back in our f of x here. So we get 2 onto x minus 6 minus 3 multiplied by x minus 6 plus 8, which simplifies to 2 onto x minus 9 and x plus 2. Let's try another one. Part C. 3 onto 2x plus 5 all squared plus 10 onto 2x plus 5 minus 8. Yet again, we have equation of the form 3 onto f of x all squared plus 10 onto f of x minus 8. So let's replace our f of x with another variable, say z in this case. So we get 3z squared plus 10z minus 8 as our expression. We cannot simplify anything right away, so let's go ahead and use our AC in this case, which is 3 times negative 8, which is negative 24. So, what are two numbers that multiply to negative 24 and add to 10? Well, in this case, our factors are 12 and negative 2. So rewriting our expression, we get 3z squared plus 12z minus 2z minus 8. Splitting the equation, we can simplify to taking a 3z out here, leaving us with z plus 4, and then minus 2 here, leaving us with z plus 4. Hence, our factors here are 3z minus 2 and z plus 4. Lastly, we need to replace our z here, and we're going to get 3 onto 2x plus 5 minus 2 and 2x plus 5 plus 4, which will give us a simplest solution of 2x plus 9 onto 6x plus 13. Factor each polynomial expression. Use difference of squares pattern. So looking at part A, we have x squared minus y squared, which factors to x plus y and x minus y, which is a difference of squares because when we go ahead and distribute that, our central coefficient cancels out, leaving us with just x squared minus y squared. So let's try B. B has 3x minus 4 all squared minus 2y minus 1 all squared. This is similar to A because it's going to use a difference of squares pattern, except here we have an f of x all squared minus an f of y all squared instead of just x and y. So when we are looking at our factors here, we're going to have f of x plus f of y multiplied by f of x minus f of y. So in this case, our f of x is equal to 3x minus 4, and our f of y is equal to 2y minus 1. So let's sub those in and see what we find. We're going to get 3x minus 4 plus 2y minus 1 as our first binomial, and 3x minus 4 minus 2y minus 1 as our second binomial, which becomes 3x minus 4 plus 2y minus 1 onto 3x minus 4 minus 2y plus 1. Simplifying to 3x plus 2y minus 5 and 3x minus 2y minus 3. And those are our factors for this difference of squares here. Let's do one more. See, 27 onto x minus 3 all squared minus 75 onto y minus 4 all squared. So this is similar to part B, yet we have coefficients attached to our binomials. But I do notice that we can factor a 3 out nicely here. So let's go ahead and do that. We'll be left with 3 onto 9 2x minus 3 all squared minus 25 onto y minus 4 all squared. From here, I notice that our coefficients of 9 and 25 are perfect squares. So when we're looking at our factors now, we can say that our binomials will be our coefficients square roots of 3 onto f of x plus 5 onto f of y and 3 onto f of x minus 5 onto f of y for our factors. So here we have f of x equaling 2x minus 3 and f of y equaling y minus 4. All right, let's look at what we're going to find here. We have 3 onto 2x minus 3 plus 5 onto y minus 4 multiplied by 3 onto 2x minus 3 minus 5 onto y minus 4. Simplifying, we get 6x minus 9 plus 5y minus 20 and 6x minus 9 minus 5y plus 20. Collecting like terms, we find 6x plus 5y minus 29 and 6x minus 5y plus 11 as our binomials here. But we can't forget that we did factor out a 3, so plugging our 3 back in, we find that 27 2x minus 3 all squared minus 75 onto y minus 4 all squared factors to 3 onto 6x plus 5y minus 29 times by 6x minus 5y plus 11 as our final answer.